All right, we're doing 3.2, lesson 3.2. All right, so back to where I was. I'm looking at this little packet that I gave you guys yesterday. And look at the very top. It's talking about your slope and it's talking about your y-intercept. So if your x value is the age in months and your y value is the height of a plant in centimeters, so look at your slope right there. It's 2.3, okay? So for every 1 month increase, we can see that the plant's height will increase by 2.3 centimeters, okay? If your slope is positive, you'll have the word increase in there all the time. If your slope is negative, you're gonna have a decrease in there at some point, okay? It's always a positive one in the denominator, so it's always gonna be for every 1 day increase, for every 1 job increase, for every 1, whatever it might be, 1 passenger increase. You're gonna see, you'll always do your change in X by a positive one, because we're going to put it over 1, but your slope, your change in y might be an increase or a decrease, okay? Also, your y-intercept, which is so important in Algebra 1, could be complete junk in AP Stat, because if it's outside of the range of data, it's called extrapolation. And I know we forecast all the time. You look at those corona, COVID things. I'm trying to find a COVID forecast from March to see what would happen in May or June or July, because we have the data from May, June, or July to see how appropriate their forecasting is, right? And you do that in econ, I'm sure. Y'all forecast about what's going to happen. We don't forecast in statistics. What we do is we interpolate, okay? Interpolation means that you're looking and making predictions interpolate inside of the data range that we have. Extrapolation is when you're on the exterior of the data and we don't know what's going to happen. We could have a tornado. It hit last night in Alabama. Did y'all hear about that? Okay, so a tornado could happen. We could have this. We could have the stock market could crash. We don't know what's going to happen on the exterior of our data set. So we do not extrapolate. But your y-intercept could be on the exterior of your data set, you know? So I could get something that says on day 0, the plant was 7 inches tall. No, it wasn't. It was a seed at day 0. It doesn't make sense. So you could get, I usually call it a crap statistic, okay? So the y-intercept could potentially just not make sense in context of the data, okay? So always keep that in mind, okay? All right, so that's what we did. Correlation coefficient, we did that yesterday. So if you would like to have an example, there is an example on correlation coefficient, and I'll cover the last one later, okay? All right, so that just gives you an idea there. So we're going to go into this beautiful y equals mx plus b, and look at this. Now, a least squares regression line is also called just a regression line, and it's also called a prediction line. And when you're writing your least squares regression line, we put a hat on the y, which just tells me that's just a prediction. So y hat, if you have a hat on top of it, then that means it's a prediction. I always call it my hard hat. It's like, man, don't beat me over the top of the head just because I made a bad prediction. You know what I mean? I'm just making a prediction, man. All right, so I put my hat on as my hard hat, okay? So that just means that it is a prediction, okay? It's not the same as your line of best fit, because we know none of us were really that great at it when we did it the first time, okay? All right, so here we go. It is a model only. Your slope is always on average, okay? We'll say on average, because that's what we're talking about. On average, the change in y over the change in x, okay? So you do have a little Mad Libs that's on that last sheet of paper. I'll give you a Mad Libs as well that I use, and both of them work good, okay? So again, we'll have, that is our little line there, okay? So always use this word when you're talking about slope. You want to say on average. For every day that increases in statistics, my average increases by 0.02 or something like that, okay? So, but you want to say on average, because it is an average rate of change. It's not based on 1 point. It's not based on 2 points. It's based on the average of all the points, okay? So you always want to say on average, okay? All right, one of the top mistakes on the AP exam is to interpret the slope as a line of best fit. So you're not going to do that, because I'm never going to do that in class, okay? You won't even see me attempt to do it any other way than the correct way, okay? Good catch. Good catch, okay? All right, like I said, you can interpolate, which means you are on the interior of the data. we are not going to extrapolate, which means we are on the exterior of the data. You can do the interior, but you do not want to be on the exterior of the data because you don't know what's going to happen outside of the data. If you want to figure out what's going to happen on the outside of the data, just wait or go to Econ and let you guys forecast as much as you want, okay? We just don't do it in AP Stat, okay? All right, so again, the least squares regression line will minimize these vertical distances. So that line is so perfectly placed that we are minimizing our vertical distances, which is pretty stinking awesome, okay? Oh, and your, write this down on this if you have it, if you can find this slide, that your least squares regression line, fun fact, one of the points that is on it is always X bar, comma, Y bar. So wherever your X bar, so here's your Y bar, they showed you your Y bar right there. That's your average of all your Y ordered pairs. And then I know that my X bar must be right here because it will always be a point. X bar, Y bar will always be a point on your regression line. Good to know, because what if I'm like, write the equation of the regression line, but I'm not going to give you any data. I'm just going to give you like these few little things, and you can write the equation of the regression line, but make sure that you do know that it does go through X bar, Y bar, okay? Again, they're trying to minimize the sum of the squares. That is our big thing. That is why it's called least squares, okay? All right, there is a residual formula, so we're going to write it on this one right here. Notice that we have observed minus predicted. I call observed actual points, okay? So let's look at this because this is a very important slide, very important slide. So your residuals, again, a residual is how far off you are from the prediction line. So I'm going to draw some stuff on here, okay? So this is my least squares regression line. This is my prediction line. Okay, y'all get so far? I know there's a bunch of other lines. This is my prediction line. Right here is a, let's just make it a point, X comma Y hat. So this is, if I wanted to know what was happening, how many calories I burned, okay, this is non-exercise activity, like fidgeting. So right here, if I go to a negative 57, X equals negative 57, think about the way that a line works. Don't you plug that in for X and it spits out Y? It's an input-output, right? Okay, but you have to have the equation of line, which I don't see here. But I do know that my Y hat, this is called a prediction. And it appears that my Y hat for that is 3.7. So I'm going to put that right there. All right, so I know that this is my predicted Y value. That's my predicted Y value. Is that my actual Y value? Is that what happened when somebody had a non-exercise activity at negative 57? No, okay. Here's a dot right here of somebody that actually had a non-exercise activity at negative 57, and it appeared that their Y value was 3. So what this is an X and an actual Y value. So this is an actual Y value. So we have a predicted Y and an actual Y, right? And the distance, that vertical distance between the point and the prediction line is called your residual. So this whole thing right here, this is called your residual. Since we're below the line, will it be positive or negative? Negative, okay? So the formula for a residual, and you might have to work backwards on your residual formula, is residual equals actual Y minus predicted Y, which is a Y hat. So you could just write it as Y minus Y hat, but then I think sometimes you forget what the Y is, right? So I always say, let me capitalize that so y'all can see this, actual Y minus predicted Y. It's AP. Y'all see that? AP? And you're an AP stat? So your residual, what if I said, okay, here's your equation. What is the actual value, or what is the predicted value? You have three different pieces of information there. So I could give you two of them, and then you could solve. But do you see, I could make you work backwards here, and you will work backwards, okay? So there will be a scenario where I could give you the residual, and then I'm going to ask you what the actual y was. So you might just have to add or subtract, some basic addition or subtraction with the residual formula. That is not on your formula sheet. You just have to memorize it, okay? Least squares, like I said, we're trying to minimize the vertical distance, which would minimize the area of the square, okay? All right, let's do this problem. So let's go ahead first. Before we even get started, let's determine what you guys believe is my explanatory versus my response. And is there actually one here? All right, calories and fat. What are we looking at? Oh my gosh, I'm getting hungry now. Chicken, a BK tender grill. Look at all these different chicken Whopper. I've never even heard of these. Okay. All right, which one is the explanatory? Which one's the response? How many of y'all have taken nutrition in here? Does anybody read a label? So carbs, fats, and proteins. So if you have carbs, fats, proteins, it's one of those like there's 9 calories for every gram of fat, or is it 4 calories for every gram of protein? Okay, so there's that relationship between those, right? So which one do you think is the explanatory and which one do you think is the response? Which one's my explanatory? Fat. Okay, so it's backwards here, okay? So I'm going to say that this is my X, that is my explanatory, and then this is going to be my Y, which is my response. Okay, so let's go ahead and put it in the calculator, and then we get to do so many fun things today. I'm probably going to get ahead of myself. It's okay. That's no big deal. All right, so stat edit. Let's put all this data in. L1, L2. Remember that L1 is the second column. If you mess up, you can just put them backwards in your table. Okay, do we have our data in? So we have fat in grams, and then we have calories. So we're going to do a lot with this, so y'all can write in the margins of what we are doing. Okay, very first thing I want you to do is graph a scatter plot. Well, we know that all plots happen over here under stat plot. So do second y equals. This is what we did yesterday. Turn it on. Make sure it says L1 and L2. And zoom 9. Beautiful. Does it appear that I might have some influential points? Do y'all see this? All right, so these are actually in line with the way that if I were to have a least squares regression line right there, they're in line with it. It's not like they're not in line, but do you know what happens when they're far out on the X and far out on the Y and they're in line with it? It's going to make your correlation stronger, okay? It's going to make that correlation stronger. All right, so now what we're going to do is we are going to find our least squares regression line. So we're going to use the button stat, and then we're going to go over to calc. So arrow over to calc, go down to 8, and now stop right there. Make sure it says L1 and L2, and then stop. All right, so we have L1 and L2. Our frequency right there, just leave it alone. We don't want to count our data more than one time. But now this is a cool one. It is not required, but man, it's pretty stinking awesome, okay? Because there's a lot of fun stuff you can do with it, okay? All right, store regression equation. So y'all have all had algebra 1, or excuse me, algebra 2. Most of y'all have pre-calculus, but we use this y equals button. Don't touch it. But this y equals button has y1, y2, y3, y4. It has a bunch of y equals, right? So what this will do is if we store this a regression equation, I'm going to put y1 right there, and it's going to store it into y1. So then I can do some of those useful stuff that I know how to do with with graphs and equations in y equals. Okay, so arrow down to that. Let me move this up just a little so y'all can see. Okay, so how are we going to store the regression equation? I have to go get the variable y. The variable y is underneath the variable key. It says vars. Okay, that's variable. So click, make sure your blinker's right there. Got to be on store regression equation. Then go to y vars, and we know we want to put it in y equals, so go to y vars. And then I know it's a function because it's a line. It passes the vertical line test, right? So function, and there's y1. So now this is what it should look like. L1, L2, nothing in frequency, y1 is there, and then calculate. All right, so what I have here is I have an awesome regression line. It tells me what my regression line is, and all I have to do is plug in my values, and I usually round to 2 decimal places, which means I might have to look at the third one. 5 or more raise the score, right? Y'all know the rule. All right, so I'm going to go ahead and write my regression equation, and then we are going to describe it. And then if you guys, once we do that, we're going to go look at our beautiful line, okay? Flip this upside down so I can do that. And do that. All right, so out to the side, I want you to go ahead and write y hat equals 266.52 plus 11.04x. Now, a lot of times in statistics, they won't write y and x. They'll go ahead and explain what the variables are in it, okay? So if you write it that way, then over here I need to write x equals fat in grams, so I know what I'm talking about, and then y equals calories. But in statistics, you might see it look like this. And that's okay as well, because then it just explains it inside and you don't have to write it out to the side, okay? But you always have to define your variables. That's a big, big thing, okay? They want to know when you're taking the AP exam that you know what the explanatory is versus the response, okay? So make sure you write it somehow and some way. So now what we're going to do is we're going to describe our slope and our y-intercept, and then we're going to go back and look at our graph and make a prediction or two, okay? All right, so when I look at this right here, this is, what is 266.52? That is my y-intercept. Okay. And my y-intercept is 0, comma a. So I know that it is 0, comma 266.52. This is fat, and this is calories. Y'all good? Now I need to write a sentence for it. So if you want to get out the back sheet of paper, I'm not going to do it exactly like this, but it will mean the same thing. Your y-intercept, it says, when the plant is 0 months old, I would predict that the height would be 1.2 centimeters. Remember, the y-intercept might not be meaningful like I went over, okay? It doesn't make sense. So what I say is right here, I predict. You need to say predict because it's coming from the prediction line. I predict that I think we're talking about chicken sandwiches, a chicken sandwich with 0 grams of fat will have, you always describe your X before your Y, don't forget that. All right, we'll have 266.52 calories. All right, so you might not love chicken sandwiches. This might not be very important to you, but at least it has a little bit more meaning than what you've done in the past, okay? And when we start talking about, COVID cases, a little bit more meaning than just our y equals mx plus b, okay? All right, now our slope is the one that gets to be a little bit trickier, so make sure that you are paying attention to that, okay? Still have to use the word predict over here. So the way that I write it, I know that this is my slope, and I know that my slope is always a fraction, right? Y's over 1. So it's going to be the change in y all over the change in x. What does my y stand for? Calories. And my x is fat. I always label it every time because it gets my mind in the right place. And you always describe your X before your Y. Okay, always. So X before Y, I know that's a positive. I know that's a positive. So all my things will say increase. There won't be any decreasing, okay? As fat goes up, calorie goes up. All right, so here we go. I predict, we like to use that word predict, also on average, because I know that this is an average rate of change. That's what slope is for a line. All right, I predict on average that for every, now what do I describe first, X or Y? X, every time. For every 1 gram of fat increase, calories will increase, again, the word increase twice because it's two positives, will increase by what? 11.04. Now that's a very basic way of saying it. You could move and wiggle those words around a little bit more to make it sound better in context, but that is like, that right there is your, Mad Libs, okay? You're always going to say, I predict on average for every 1 blankety blank increase in whatever your X value is, okay? Your Y value will increase or decrease by this amount, okay? All right, so that's how we do it. Now, go back to your graph. Let's turn this on. Go back to your picture. And if you press Zoom 9 now, get your calculator out. Press Zoom 9. Let's go. Ready? 1, 2, 3. Zoom 9. Oh, look how beautiful that is. It's so pretty. All right, so that's kind of cool. So again, least squares regression line, we minimized all of those vertical distances much better than our eyes could do. Now, do y'all remember how to do y'all remember second calc value? Did you ever use second calc value? Okay, I'm going to go back to my data. By the way, with your y-intercept, did we have any, look at your data, did we have any fat grams at 0? 0 fat grams. Okay, so this is actually called what right here? Extrapolation, right? This is extrapolation. It's outside of our data range. All of the sandwiches we had fat in them. So it's not going to be an accurate answer. Could you have a chicken sandwich without fat? Okay. All right, so looking at that, now let's make one for, what I can do is trace, press the trace button. So just in case you're wondering, it is going to bounce around by the way that they're listed in your calculator, which is frustrating because when I press to the left or press down, it doesn't bring me to the next button or the next one. It will bounce around everywhere. You might have to press the up button, press the, trace. Okay, I'm pressing the right and left. So now it'll take me to all the different points, but it's doing it in the way that the list is ordered, okay? All right, so with that said, why don't we predict, since there's 19, why don't we predict what the line says at, let's see, I want to get to these little ones right here. Okay, these right here, 13 grams of fat. So I have one at 13 grams of fat that's 380, and I have another one at 13 grams of fat that's 360. Do y'all see that? So if I wanted to make a prediction at 13, we're going to use that calc right there, second calc value. You've done it before, I'm sure. So go over here, second calc. If you go to value, that is just an X value. And it's going to ask you what X would you like to predict, and we're going to put 13. Okay? So now let's go ahead and find the residual for this, which is kind of cool. So we can find our residual. And actually, I would have two different residuals here because I know that one of these was at 360. Okay, let's just say, I think it was this one, 13 and 360. So if I asked you what is the residual for that point, 13, 360, how would you find your residual? From the y hat, right? So we're going to do actual y minus predicted y, which is a y hat. So our actual y was 360. And our predicted y is right here, 410.03. Should I get a negative or positive residual? Yeah, a negative because we are below the line. I don't know why my air's on. I tried to turn it off. I apologize. All right, negative 50.03. All right, so that's my residual, okay? Now, again, this line is so perfectly placed that I should have, y'all remember with a best fit line, you wanted some above and some below. Do y'all remember that, right? About them out the same. So we want to see that, okay? But it is perfectly placed. So this is going to lead me to something called a residual plot. So go back to Stat and go to Edit. And a residual plot is something that tells me if my line is really a good fit, okay? So what if I had COVID data and my COVID data looked like this, and then I tried to fit a line to it that looked like this? Okay, so, some are above and some are below, so maybe I have half above and half below. Yay, it's a great fitting line. Is that the best fit line? No. So what you would see is on a residual plot, okay, so a residual plot is all your x values, so that would stay the same. And then this obviously is your y values, but here, this would be your residuals. Okay, so how many, I would have a negative residual, a negative, a negative, a negative, a negative. How many is that? 2, 4, so I would have 7 negatives, right? And these would be, and it would kind of look like that because it's kind of getting closer to the line. And then I would have 1, 2, 3, 4, 5 positives. And it almost takes on the same picture as the original graph. So do y'all see that there's kind of like a little curve here? Do y'all see that? That's bad. A residual plot should show no pattern, okay? So I'm going to show you how to do a residual plot in your calculator. It should say, if there is no pattern, that means that a regression line is a good fit for the model. But if you do see a pattern, then that means that your original one's probably not linear, okay? Because if there's a curve in the original one, you're probably going to see a curve in the residual plot, okay? And you can kind of think as this baseline is kind of as your regression line, okay? So some are below, some are above. So let's do the residual plot for this, okay? Turn it on. Now this is really cool. If you happen to want to see your residuals, and you really never ever have to do this, but as soon as you stat calc 8, it stores all your residuals. You don't have to find the residuals by hand unless a problem forces you to, okay? So go up and highlight L3. I mean, there's a bunch of different ways you can find residuals. I already know my equation, right? So couldn't I plug in all of these x values into my equation and get all the predicted y values back? Could I do that? Yeah. And then couldn't I subtract all of my predicted y values from all my actual y values? And then wouldn't that give me my residual? So there's a way I could fiddle and do this. But what I'm just going to show you is that they're already stored in your calculator. Do you see the word list above the stat button? Y'all see that? So go to second. Well, highlight L3, make sure L3 is highlighted, and then go to second list and arrow all the way down until you get to resid. And it should be there if you ran a stat calc 8 already. And it will be your last problem's residuals if you hadn't ran a stat calc 8 on this problem. Do you understand? So make sure that you do that. So I'm going to do residuals, press enter, and those are all of my residuals. Okay? So those are my residuals, and we actually just found this one, didn't we? Which is the one that we found, the 13 grams and 360? So we found one of these already. All right, so that's my residuals. Just in case you wanted to eyeball them and see them, okay? That's where they are. Now, let's do a residual plot. Ready? Go to second y equals. This is in your packet. Just in case inquiring minds want to know, it is at the very, very bottom of, it's called page 16, but it's like your third page, okay? So creating a residual plot. All right, so this is what we're going to do. Press enter. We're still going to do a scatter plot. We want our x values on the x-axis, and we want resids on the y-axis. So we want L1, that's where my x values are. And then right here, we want to put the word resid. Where am I going to go get that word resid again? It says it right there, list. Do y'all see that? So I'm going to have to go down to that word list. So highlight L2, and we're going to change that to go to second list and go all the way down to resid. So when you're trying to do a scatter plot, you're going to do L1 and the residuals, okay? And remember, the whole point of a residual plot is to tell you whether or not the regression line is the best fit for your data, okay? So go ahead and zoom 9. And I know our least squares regression line might show up somewhere. And okay, no, it doesn't show up. Okay, so there we go. So as long as we see, and this is the way I told my senior statisticians when I taught senior stats, no pattern equals good fitting line. Okay, so you do not want to see a pattern there. Okay, and don't let your eyes, be like, oh, I think you know how we are. We always want to see a pattern or skewness, right? So as long as you don't see a direct pattern, then it is a good fitting line. It is definitely a good fitting line, okay? And that one's great. So no pattern equals good fitting line there. So that one's fantastic. I don't see a direct pattern. I don't see a curve like the one I just showed you. If you see a curve or something that kind of looks parabolic or, exponential, then your original data is probably parabolic or exponential, quadratic or exponential, okay? All right, so there we go with that. That is our residual plot. And I'm going to go back to the notes real quick just to make sure that I have everything covered. And then we'll move on. All right, I know that's a lot of information to take in, but that just gives you a good idea of the least squares regression line, how to interpret it, what a residual plot is. Okay, again, how do we interpret strength, direction, and form? I was about to say shape, center, spread. Strength, direction, and form, okay? How strong was our fat grams and calories? How strong is it? What do you find in the calculator? Tell me my strength. Correlation. Go find it. What is it? You can usually just press enter, by the way, again, if you just ran it, and it'll pull it back up. You don't even have to go to stat calculate. If you press enter right now, it might just pop back up. But did it? Awesome. Okay. All right, so my R value is 0.9599. Is that in terms of fat grams or calories? Is your R in terms of fat grams or calories? No. Does it have a unit of measure? No. Okay. What is the smallest number that your R could be? -1. What's the largest? +1. So if I told you I got a correlation of 1.07, would you be like, man, that's the best correlation ever? Or would you say, man, we need a new stats teacher, right? Okay. One or the other. Okay. All right. So we have a 0.96. So that is strong, positive, linear, strength, direction, form. Strong, positive, linear association. All right, so we can do that. We found the equation of the regression line. We did find the meaning of the slope, and we did find the meaning of the y-intercept in context, and we did find a residual, but I did not do it for 39 grams of fat. We did it for 13 grams of fat, okay? So we have done all of that good stuff. All right, so a couple of different things that you need to know. This formula is on the AP formula sheet, and this is really, really fun right here, okay? Notice that what if I do not know my slope? What if I don't know my slope? So we're going to try this with our fat grams. Okay, if I do not know my slope, this is on your AP formula sheet, you can use this formula to come up with your slope. It is your R correlation times the standard deviation of y over the standard deviation of x. So it's still y is over x is y is over 1, right? Standard deviation of y over standard deviation of x. And it always goes through x bar, y bar, I already said that. All right, tell me what my B value is for this. Go ahead and turn it on. What was our B value? 11.04? All right, so our B value is 11.04. Okay, now what I want you to do is, where do you find this value? Where do you find this? You're going to go to, let's go to 2 variable stats, because now we have 2 variables, right? So I want you to go to stat calc and then 2 variable stats. All right, so go to stat calc, go to 2 variable stats. There you go. And press enter all the way through, and it will give you lots of information. It does give you X bar, Y bar, so we already know that my line passes through 18.11, comma, 466.44. Because it gives you your X bar, Y bar, right? All right, and then my standard deviation of X is, I'm gonna write it down here. My standard deviation of X, 12.18. Is that what y'all got, 12.18? Maybe, good, okay. And then arrow down, and my standard deviation of Y is 140.07. And the only thing that I'm missing here is what? To solve this out, what am I missing? My R, okay? So where do I find my R? Stat Calc, what? 8. Stat Calc 8. Go back, and my R, I think it was 0.9599, so 0.96. Now, I want you to put this in your calculator, and what should you get back? 11.04. Confirm it, please. All right, did everybody get 11.04? All right, so now I'm going to put my calculator away, and I'm going to say, well, what if they only gave me this, and this, and this, and I have this information. They didn't give me L1 and L2. I had no data to put in, but they gave me this information. So let's go back to Algebra 1, Algebra 2, where you had to find your slope, and you had to find your y-intercept, okay? Because I'm making you, what if I asked you to write the equation of y equals a plus bx? But they didn't give you the data. You couldn't stat calc 8 it, okay? And I'm going to give you an example tomorrow. But if I give you this, and I'm asking you to find the slope, well, we just did that. We're going to have to use this formula right here, which we did. And we got 11.04. Now, how could, and my slope is my b value. How could I find my a value? How could I find my a value?
Do I have that b value?
Yes, it's right up there.
Thank you.
You're welcome. I thought it was kind of like my tip for teaching you statistics.
No, I need it.
Are you sure? Okay.
Thank you.
You're welcome. Have a good day. All right, so now that I have my slope, let's go ahead and figure out my y-intercept. So this is the way that I do it. So we have y equals, this will bring back memories, a plus bx. So what do I know? I know my slope, and don't I know my x bar, y bar? So couldn't I solve backwards for my a value? And we already know what it should be, so try it. I want to see if you actually get your a value back, okay? So we know what our a value should be because, you know, we were privy to information in our calculator. But I'm going to go ahead and plug it in and see what happens. So, and you will have to do this by hand without actual data. I'll just give you some pieces of information and you'll have to plug it in. All right, so our a value should be 266.52. So we're going to go ahead and put this in and see what we get. All right, and I got 266.51. So I multiplied these, I subtracted them over, and I got 266.51. So I know my a value, and I know my b value. And you can do that from just knowing a few pieces of information. You don't have to know the entire data set. Is that wild? Are we good? Okay. All right, so that's one way of working backwards, just to show you that, okay? If you want to try another example, and then I promise I'm finishing right now, but if you look at this right here, this was hours of sunshine and the number of visitors to a water park. Notice that both of these are in, and this is where you have to be smart about what you do. Bless your hearts. Be smart about what you do. It says the number, hours of sunshine, and the number of visitors. It gives you your R value. Do you notice both of these say X bar? It's just because somebody ran one variable stats and not two variable stats. You see that? Okay. All right. That was me. But anyhow, so you have to look at this. Which one of these, and what if they don't label it, and they tell you, well, which one's the hours of sunshine and which one's the number of visitors? I hope that you guys can be able to tell the difference, right? If I ask you which one's your GPA and which one's your SAT math, could you look at the numbers and tell me which one should be a GPA versus an SAT math? Absolutely. Okay. All right. So you look at this. So you'll need your X bar, Y bar, and you can mark that as X bar, Y bar. This is your standard deviation of Y. So you'll need this, and you'll need your standard deviation of X. You'll need your R value. All right. And that's pretty much what you need to be able to work backwards to find the equation of a line. Okay. And right here, you always do your B before you A because you want to be a best at arithmetic and statistics, right? Okay. All right, so make sure that you do your B before your A. So those are the 5 pieces of information you need to work backwards, so y'all can try that one on your own, okay? All right, I think I'm done. All right, so you have a few minutes. You guys can work on homework if you want. If you need the homework book, let me know about that. And make sure you're studying for your vocab on Friday. 17 words, look at your bold, italicized. If you come up with 19 words, study all 19 of them, okay? So make sure that you're prepared for that. And that's pretty much it. I'll have a good day.